Hopefully you can see me. I'm disappointed not to be there in person, but with the government shutdown, we decided it was best not to spend funds on travel. Hopefully this is the end of that and we won't have to deal with that again. I'm very grateful to the SBAG for inviting me to give a talk on this. What I'm going to be talking about is a pre-decadal study that we are doing for the Heliophysics decadal survey that's coming up after the Planetary Science decadal survey. And this is a unique mission because we have been tasked as part of this mission to reach across divisions and engage people and scientists from the astrophysics community and from the planetary community to look at ways that we can make this a mission that is cross-divisional and can address compelling science goals for the other two divisions as well. And what my goal is with, yes?
I think you're showing the presenter view. Could you swap to the view where we see the full screen, just so we can see the nice graphics?
Does that work?
No, we're still seeing the presenter. Oh, there we go. Okay, yes, perfect.
Oh, okay.
Thank you.
Perfect. All right, excellent. So my goal in giving this presentation to SBAG, and I'm very grateful to have this opportunity, is to engage this community because there are potential targets that we could focus on if this mission is able to fly that would definitely add science goals or address science goals for the small bodies community. And we, as part of this study, because we have been tasked by NASA to do this study, we want input from the community as much as possible on where the interests are, what interesting targets you would like to see us go after. So I include in this emails of specific people that you can get in touch with to get involved if you're interested as we go along. So what I'm showing here is a graphic that has come out of it. We created this as an updated version of a graphic that was used for a Keck Institute study for an interstellar probe that originally had the goal of going out to a certain distance and looking back and using the sun as a gravitational lens. And that was more of an astrophysics mission concept. What we are looking to do is something that is intentionally going to do what the Voyager missions have been able to do because they've lived so long. And that is to explore outside of the heliosphere and learn to understand our own heliosphere in the context of the greater galaxy, looking at our heliosphere as an astrosphere. So we would be designing a mission that would go out intentionally to 1,000 AU. And what we've been tasked with is to look at only current and near-term technology to see how we could actually get out there and reach 1,000 AU with a goal of 50 years. So we're in the first stage of this study. We're just finishing up the first stage, and it's mainly been an engineering study at this point, looking at how we can get moving quickly on our way outside of the solar system. We've looked at three options for doing that. One of them is just a gravity assist by Jupiter and looking at how much speed we could pick up by just doing a flyby of Jupiter. And that's how New Horizons managed to get the velocity that it needed to get out to Pluto. And the second option that we've looked at is to do a powered gravity assist by Jupiter, which is where we get to the closest approach to Jupiter, and then we fire our rockets and then go out faster and pick up more speed. The third one that we are studying, we are drawing on what we've achieved with the Parker Solar Probe with a solar shield that allows us to get in close to the sun. And we are looking at what is known as the Oberth maneuver, where you go to Jupiter and you do a reverse gravity assist that pulls you to where you fall in towards the sun. And then you do a gravity assist using the sun and getting as close as possible and fire an engine when you are as close as possible to the sun. And we're looking at those three options. We haven't found a way to get up to a speed that would get to 1,000 AU within 50 years, but we are getting close to it, and it looks like the Jupiter gravity assist is a pretty reasonable way to do that. We're still trying to find a balance between the size of shield you would need to get as close to the sun as you need to get without just completely melting the spacecraft. So it's a challenging engineering study, and it's a lot of fun looking at something that we could actually see happen within our lifetime. And so that's the goal, and that's where we've gone so far. We're hoping to get an extended study, and we want to, as part of this, engage more with the small bodies community and start getting more feedback on what specific targets would interest you, because we are tasked with addressing not just heliophysics goals of going outside of the solar system, or outside of the heliosphere and looking back, but also looking at what we can explore on the way out there. We are also are planning on submitting a white paper to the Planetary Science Decadal Study so that we can start encouraging and are advocating for cross-division efforts like this on other missions as well. So the science goals of this, there's 4 science goals, or 4 categories of science goals that we're looking at. The main one, because it's a heliophysics mission, would be to characterize our heliosphere and the interstellar medium and try to understand that in the context of other astrospheres. What I'm showing here is an image that was taken with a ground-based telescope of an astrosphere around another star, and that's what we're hoping to get an idea of what our heliosphere would look like if you went outside of it and looked back. And so that would be the primary goal of the mission, and the direction that we would fly would be defined by that. Another goal, which is more in the astrophysics area, is to look at the circumsolar disk, but this is also relevant to planetary science, because the circumsolar disk of dust is the remnants of the formation of the solar system, and understanding how dust is distributed within our solar system helps us to get a better understanding of the processes involved in the formation of the planets. And then what is of interest to this group would be the planetary science that we could do on our way out of the solar system. And what is really standing out as one of the most compelling targets is to fly by at least one Kuiper Belt object. We would be traveling at very high speeds, so changing the direction of the spacecraft to go by multiple objects could be very challenging, but we would target at least one. We also want to look at the possibility of giant planets, but I think looking at where we go as far as the trajectory is for the heliophysics science, a Kuiper Belt object would be of greatest interest and the most possible. And then finally, we want to look at ways that we can contribute to exoplanet science, possibly by, on our way out, looking back at the Earth in transit and seeing what the Earth looks like in transit from different distances from the sun, and then looking at the other planets as they transit in front of the sun as well. And so that's one of the things that we could contribute to exoplanet science. So this is the team that we have put together. Ralph McNutt is the principal investigator of the study. I'm the deputy project scientist, and feel free to contact me. My email is up here. I'm very interested in hearing from the community on what you think are interesting targets and what are important science goals to explore. We've broken the science team into 4 working groups, and the leaders of the working groups are listed on the right. Kirby Runyon is in charge of the Kuiper Belt object portion of the working group, and then Abby Reimer is in charge of exoplanets and giant planets. So feel free to get in touch with any of us if you have any questions or if you have any input or suggestions, because we do want community input for this. So the trajectory is going to be defined by what trajectory is needed to answer the heliophysics questions. And there is some debate still as to whether we would want to go out the nose or we would want to go through the ribbon here. This is the Ibex ribbon, which was observed by the Ibex mission, and it's not fully explained, so flying out through it is of interest to some people. Or if we want to go off by about 45 degrees from the nose, that would be a way to go out and look back and see if the heliosphere looks like a comet coma, or if it looks like a sphere, as some have suggested that it is. So the heliophysics goals will be defining that. What I'm showing here, and I'll zoom in a little bit, is the region that we would be focused on. And that region is has several Kuiper Belt objects that would be of interest. And so we've been focusing on trying to understand each of these and what they would contribute. One of them that we've focused on quite a bit is Quasar, because It's smaller than Pluto, but there have been observations of crystalline ice, water ice on the surface, and there may be methane on the surface. And I think there was one paper suggesting that it might even have an atmosphere, even though it is smaller than Pluto, but it's farther out, so it may have retained some volatiles. So it would be an interesting object to fly by and observe, and a very interesting one for comparative planetology with Pluto. So the other types of planetary science that we could do is during a Jupiter flyby, we could do Jupiter science. We would have instruments that would be useful for magnetospheric science, and we could possibly do some imaging of the moons. There are other spacecraft in the Jupiter system and going to the Jupiter system that are going to achieve more, but while we are there, we could take coordinated measurements with these other spacecraft and do some comparative observations during that. There is a slight possibility of maybe doing a flyby by one of the ice giants, but their position in the heliosphere is not ideal for the direction that we want to go in for heliophysics science. So we're looking into these, but these are not as likely as flying by a Kuiper belt object. So the other science is going to be a Kuiper belt object science, or large, and we want to go for a larger Kuiper belt object, or maybe something in the middle. And I talked a little bit about Quasar being one that we're really focusing on as potentially very interesting. The science goals that we would try to address as far as planetary science goals are, that come from the Decadal Survey, are primarily: how did matter in the solar system and interstellar medium originate and evolve? And taking observations of smaller bodies in the outer solar system is very important, looking at their volatiles on the surface, any atmospheres they have, looking at how they've evolved. Like Pluto is clearly differentiated and may have had a subsurface ocean. Other bodies, the M69 flyby is also very interesting, because it's a different type of small body in the outer solar system. So we've only tasted a small amount of information that is available out there in the outer solar system. And we hope that with Interstellar Probe, we can add to that by at least visiting one other object that would possibly revolutionize our way of thinking about origin and evolution of the solar system. Other goals is we'd look at surface compositions and volatiles, look at geological landforms, processes that take place on small bodies. Quasar in particular, looking at whether it could have possibly had a subsurface ocean, does it still have an atmosphere? And then the bigger picture of the size frequency distribution of Kuiper belt objects. One of the things that the New Horizons mission has been doing is been making distant observations of other Kuiper belt objects, and that's something that we would aim to do if this mission is able to fly. So I kind of rushed through that, but I wanted to go through it quickly so that I could give an opportunity for any questions. And I'm putting up my email address and Kirby Runyon's email address again. If you're interested in getting in touch with us, we welcome any input, and we want broad community involvement in this. So I'll take your questions.
Thank you, Kathy. Questions? In the back.
Just a quick question, Mr. Bauer, University of Maryland. Have you considered the possibility of going by a long period comet near its path limit, or at least when it's well beyond its highly active state?
That would be great science. We have not looked at any long period comets and what their orbits are, but I think that is something that would definitely be of value to add to our study. Thank you for suggesting that.
Hi, Kathy. This is Andy Rick at APL. Could you give us, I think you've already told me the question, I forgot, a sense of what the flyby speeds would be?
it's a little bit hard to hear, but I think that question was about the flyby speeds, and it would, the flyby speeds would be much faster than the New Horizons flyby of both of its targets. So that is something that we need to take into account. In fact, we've already started looking at, in particular, imaging constraints and what type of camera we would need to be able to get high resolution images of any Kuiper belt object that we fly by, because the velocity of the spacecraft would be an important consideration. It's going to be much more challenging than New Horizons was.
Thank you. Other questions? All right, thank you very much.